Hello student, welcome to our second lesson where we are going to continue with the heat capacity, specific heat capacity in the units, but in here we are going to look at methods of determining specific heat capacity. We start with the first method, we call it the method of mixtures. Now in this one, we have that a relatively hot substance is mixed with a relatively cold substance. So it implies that heat energy will be transferred from hot body to cold body until they acquire the same body temperature. And at that particular time, we say that they have acquired thermal equilibrium. Therefore, heat lost by hot substance will be equal to heat gained by the cold substance. That is, the heat gained must be equal to heat lost. MC change in theta lost must be equal to MC change in theta gained, where M is the mass, C is the specific heat capacity, and the change in theta is the change in temperature. Now, we move to determining specific heat capacity of a solid using the method of mixtures. Now, we have a hot object. This hot object is transferred from boiling water into cold water in calorimeter. This boiling water must be either in a boiling tube that is boiling or any other source. And we have the calorimeter as shown. A calorimeter has a wooden box that is in between the wooden box and the calorimeter itself. We have a lagging material. This material will ensure that the heat is not being wasted or lost to the surrounding. And again, we have covered with the insulating lid. This again minimizes the heat loss to the surrounding. Then we have the change in temperature that is measured using this thermometer. We have the stirrer, this one, that will stir the liquid to ensure that we have a uniform temperature. Then this is our metallic block. So we have moved this metallic block from a boiling water and we have placed it inside the calorimeter. Then we have stirred to ensure that we have uniform body temperature. Then after doing that, we proceed as follows. The mixture is stirred and final temperature recorded. Then the specific heat capacity of the solid is calculated as follows. Heat lost by the metal must be equal to heat gained by calorimeter and stirrer plus heat gained by water in calorimeter. And when we are doing this experiment, we assume the following, that 1, there is no heat that is lost to the surrounding, and heat is not absorbed by any of the apparatus that are used to carry out this experiment. Then for the precautions, we have that 1, the calorimeter should be highly polished. And number 2, the calorimeter should be heavily rugged. And number 3, the calorimeter should be closed with an insulating lid. That is the lid that is made up of insulator. And this will minimize the heat losses to the surrounding. Then after that, we move to example. A lagged copper calorimeter of mass 0.5 kilogram contains 0.4 kg of water at 25 degrees Celsius. A metallic solid of mass 1.2 kilogram is transferred from an oven at 350 degrees to the calorimeter, and a steady temperature of 50 degrees Celsius is reached by the water after stirring. Calculate the specific heat capacity of the material of the solid. We are given that the specific heat capacity of copper is 400 joules per kilogram per Kelvin, and that of water is 4,200 joules per kilogram per Kelvin. We proceed as follows. Heat lost by the solid is equals to heat gained by the water plus heat gained by calorimeter. So the heat lost by the solid will be given by the mass of the solid multiplied by the specific heat capacity of the solid and then the change in temperature. Then we have the heat gained by the water, mass of water times specific heat capacity of water times change in temperature. And the heat gained by the calorimeter is mass of the calorimeter multiplied by the specific heat capacity of calorimeter and then change in temperature. After writing the formula, we substitute the values as follows. We have 1.2, that is the mass of the solid, this one that is given. Then the specific heat capacity of the solid is what we are looking for. And then the change in temperature. The temperature is falling from 350 degrees Celsius to 50 degrees Celsius. That way you get the change. That will give you 300 degrees Celsius. You come to water. The water is 0.4. Then the specific heat capacity of water is 4,200. And the water is falling, or it is rising the temperature from 25 degrees Celsius to final temperature, which is 50 degrees Celsius. Again, you have 50 minus 25. Then we have the mass of calorimeter that is given as 0.5. Then the specific heat capacity, remember calorimeter is made up of copper. Therefore, we use the specific heat capacity of copper, which is 400 joules per kg per Kelvin. And the change in temperature again is rising from 25 degrees Celsius to 50 degrees Celsius. After multiplying all these values, this will give you 42,000 and this will give you 5,000. When you add, and then you come on this other side, 1.2 multiplied by 300, you will get 360. When you add and you divide, you're going to get that the specific heat capacity of our solid is 130.56 joules per kilogram per Kelvin. Then after that, we move to determining the specific heat capacity of liquids using methods of mixtures. Now, when we want to determine the specific heat capacity of a solid, of a liquid, we use a solid of known specific heat capacity. That solid now is transferred in a liquid that is inside the calorimeter. So the water that was inside the calorimeter is replaced with a liquid whose specific heat capacity is to be determined. And then after replacing the water and using the solid of known specific heat capacity, then to get the specific heat capacity of the liquid, we proceed as follows. We have that heat lost by the hot solid will be equal to heat gained by calorimeter and stirrer, and then plus heat gained by liquid in calorimeter. We have an example. A block of metal of mass 0.15 kg at 100 degrees Celsius was transferred to a copper calorimeter of 0.4 kg containing a liquid of mass 0.8 at 20 degrees Celsius. The block and the calorimeter with its content eventually reached a common temperature of 40 degrees Celsius. Given that the specific heat capacity of aluminium, that is aluminium 900 joules per Kelvin per kg, and that of copper is 400 joules per kilogram per Kelvin, calculate the specific heat capacity of the liquid. Remember here, we are using the copper calorimeter and our metal block is aluminium. So we proceed as follows. Heat lost by the metal block is equals to heat gained by the liquid plus heat gained by the calorimeter. So we proceed as follows. We have the mass of the block, specific heat capacity of the block, and the change in temperature of the block. Then we have the mass of the liquid, specific heat capacity of the liquid, then change in temperature. Then we have mass of calorimeter, specific heat capacity of calorimeter multiplied by the change in temperature. After that, we key in the values. We have the mass of the metal block as 0.15 kg. Then we are using the aluminium, that is the specific heat capacity 900. Then the temperature is changing from 100 to 40. That is our common temperature here. So 100 minus 40. Then when we come to the liquid, we are told that it contains 0.4 kg of liquid, that is 0.4. Then multiplied by the specific heat capacity. The mass is 0.8. That is what we are having as the mass of the liquid. Then the specific heat capacity is what we are looking for. And then finally, we have the change in temperature, because now the water or the liquid was at 20 degrees and the final temperature is at 40, then the change will be 40 minus 20. That is for the liquid. Then we come for the calorimeter. We have the mass for the calorimeter is 0.4. The specific heat capacity is 400 joules per kilogram per Kelvin, and the change in temperature is coming from 20 degrees to 40 degrees. That is 40 minus 20. So after multiplying these values and these values, you will get that you will have 8100, this part. Then you subtract this part, which will give you 3200. Then when you multiply 0.8 multiplied by 20, that will give you 16. You divide by 16 to get the specific heat capacity of the liquid. When you key in, and I'm telling you, you practice, you key in these values in your calculator, and you'll find that you'll get the same results. So the specific heat capacity of the liquid will be 306.25 joules per kilogram per Kelvin. Then from there, we move to electrical method. That was the method of mixtures. In this method, electric heating coil supplies the heat energy, which is absorbed by other substances. So in other words, we have now changed. Instead of transferring the hot object to the cold object, now we are heating the object using the electrical method. Now we see how we can determine the specific heat capacity of a metal block using the electrical method. We have the setup as shown here. We have the electric heater that is here. We have the metal block that is having the thermometer inside and a lagging material. So in other words, if you look at this arrangement, we are heating the metal block directly. We are getting the heat from the source here. We have the power. We have the heater that is now having an opening, and you are putting the heater inside the solid and the thermometer inside the solid. Then after that, we proceed as follows, that electrical energy supplied by heater, and the electrical energy is always given by the power times time, and the power is given by voltage times current. Then you multiply by time to get the quantity of heat that is being supplied. That will be the same as heat gained by the metal block. And the heat gain will be given by the mass of the metal block multiplied by the specific heat capacity of the metal block, and then multiplied by the change in temperature. Then precautions. When you're using this, we have the precautions. One, the metal block must be highly polished and heavily lagged. Highly polished to ensure that there is no heat, being lost to the surrounding. And again, we are lagging using an insulating material to ensure that again there is no heat lost to the surrounding. Then the two holes should be filled with high oil to improve thermal contact with the heater and the thermometer. Remember, we have the two holes inside the metal block. So these holes, you must ensure that they are oily, they are oiled, that this will improve the thermal contact. Then we look at an example here. A metal block of mass 0.5 kilogram is heated electrically. If the voltage reads 20 volts and the ammeter 4 amperes, and the temperature of the block rises from 25 to 95 in 80 minutes, calculate the specific heat capacity of the metal block. We proceed as follows. The heat supplied by the heater is equals to the heat absorbed by the metal block. So the heat supplied by the heater is VIT, and then the heat gained or heat absorbed by the metal block will be the mass multiplied by the specific heat capacity and then change in temperature. So we proceed as follows. V is 20, I is 4, and now we have the time. Time is 80 minutes, so we convert it into seconds, so we multiply by 60. That will give us the heat supplied, the amount of heat supplied. We come on our right hand side. We have the mass of the block as 0.5. The specific heat capacity is what we are looking for. Then the change in temperature, it's coming from 95, that is 25 to 95. So it will be 95 minus 25. And when you subtract, you will find that these values will be 35 CB, and these values will be 38,400. So to get the specific heat capacity, you divide by 35, and that will give you 1097.14 joules per kilogram per Kelvin. That will be the specific heat capacity of our metal block. Then from there, we have determining specific heat capacity of a liquid using the electrical method. As you can see here, this is the arrangement. We have the water inside, and then we have the heating coil, we have the calorimeter, we have the wooden block. Again, this is to ensure that there is no heat loss to the surrounding. We have a cardboard cover Remember, this must be a poor conductor of heat. Then we have the stirrer. It is stirring to ensure that we have uniform temperature. And then we have the power that is being supplied here. We have the voltmeter and the ammeter to give us the voltage and the current so that we can now get the amount of heat that is being supplied by the electrical energy or the electrical heater. Then, after getting this set up, we are supposed to record the voltmeter reading, the ammeter reading, and of course the time taken. And then finally, we are also supposed to get the mass of the water and also the final temperature and the initial temperature. After getting those readings, then we proceed as follows. Heat supplied by the electrical heater is equals to heat gained by the water plus heat gained by the calorimeter. So the heat supplied by the electrical heater will be VIT. Then the heat gained by the water will be the mass of water multiplied by the specific heat capacity of water, then multiplied by the change in temperature. Heat gained by calorimeter will be the mass of calorimeter multiplied by the specific heat capacity of calorimeter multiplied by the change in temperature. Then we look at an example here. In an experiment to determine the specific heat capacity of water, an electric heater was used. If the voltmeter reading was 24 volts and the ammeter reading 2.0 amperes, calculate the specific heat capacity of water if the temperature of mass of 1.5 kilogram of water in a 0.4 kg copper calorimeter rose by 6 degrees Celsius after 13.5 minutes. We proceed as follows. Heat supplied by the heater should be equal to heat gained by water plus heat gained by calorimeter. We have that VIT is equals to mass of water multiplied by specific heat capacity of water multiplied by the change in water or a change in temperature. Then plus mass of calorimeter multiplied by the specific heat capacity of calorimeter, then change in temperature. Then we key in the values. We have the mass. The V is 24, the amperes or the current is 2, then the temperature is 13.5 minutes. So we have to multiply by 60 to convert that into seconds. Then the mass of water is 1.5. Multiplied by the specific heat capacity of water is what we are looking for. Then multiplied by the change in temperature, which we are given as 6 degrees Celsius. Then the mass of calorimeter is given as 0.4. We are using copper calorimeter, and the copper calorimeter has a specific heat capacity of 400 joules per kg per Kelvin. And again, the temperature is changing with 6 degrees. So after that, after multiplying, you multiply these values, you'll get that 8,880. And when you multiply this value, that is 0.4 times 400 times 6, you get 960. Then when you multiply this 6 times 1.5, you get 9. So to get the specific heat capacity of water, you subtract and then you divide. And when you do that, you'll get that it is approximately 4,213.33 joules per kilogram per Kelvin. That way, you're able to get the specific heat capacity of water. Then from there, we have the assignment. The assignment is testing what we have just covered. So ensure that you practice a lot and then come and attempt the assignment. Thank you, and let us meet in our next lesson.